Here, I've drawn the thing a little more correctly and labeled the points correctly. The circle we just saw, the r equals cosine theta shape. Now it's still not a particularly good circle, at least a little bit squarish, but got the angles pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 labeled. Now let's zoom in on some of the labeling of the points. And we see that I've got the 0, 1 that I had before, but I've crossed it out and indicated that that's backwards. Okay? It should be 1, 0, or alternatively negative 1 pi. The point here should be labeled with r first, then theta, 0.71 pi over 4, negative 0.715 pi over 4. And the point here is 0 pi over 2, or 0, 3 pi over 2. And down here, our point is negative 0.713 pi over 4, 0.717 pi over 4. Okay? Again, we've gone around the circle once for the angles between 0 and pi, and then once again for the angles between pi and 2 pi. Now we've proved that r equals cosine theta is indeed a circle. Remember, a circle is a quadratic form. You have x squared and you have a y squared, then you might have some x's and y's. Now note that this circle is not centered at the origin, so we're probably going to end up having to do some completing of the square and so forth. But here's what we do now. Okay, r is the square root of x squared plus y squared, right? Okay, what we're going to do is we're going to convert r equals cosine theta to rectangular coordinates. It means we're going to substitute square root of x squared plus y squared for r, and also the cosine of theta is just x over r, which is x over the square root of x squared plus y squared. So for cosine theta, we're going to substitute x over square root of x squared plus y squared. That's going to go in here. This is going to go in here. So r cosine theta becomes square root of x squared plus y squared equals the cosine theta x over square root of x squared plus y squared. Multiplying both sides by the square root of x squared plus y squared, which ought to be a natural reaction at this point. We want to multiply through by common denominators. We have x squared plus y squared equals x. Okay, so now if we take x squared plus y squared equals x, we can simply complete the square and do the usual things to determine the center and radius of this circle. Well, first of all, we're going to subtract x from both sides, get all our x's together and all our constants together over here. We don't have any non-zero constants, so our right-hand side is just 0. Now y is already squared. It doesn't have just a y term on it, a linear term with y. So we don't have to do anything with y. But the x squared minus x, we have to add a 1/4. The x squared has a coefficient of 1. Minus x has a coefficient of negative 1. Taking half that, we get 1/2. Squaring that, we get 1/4. So that's what we're going to have to add here to get a perfect square. And of course, we add it to the other side of the equation also. When we complete the square, we can either add and subtract it where it is, or we can add it on both sides of the equation. And this time we add it on both sides of the equation. That gives us x minus 1/2 quantity squared plus y squared. And the 1/4 is, of course, 1/2 squared, telling us that our circle is centered at 1/2, 0, and has a radius of 1/2. Now, if we compare this with the figure, is it reasonable that we could center a circle here at 1/2, 0, and have a radius of 1/2? Well, 1/2, 0 is halfway between the pole and the point, which should read 1, 0, remember. Okay, so it's halfway between here and here. That's good. That's a good place for the center. The other part of that is that the radius is 1/2, which means, well, distance from here to here is 1/2. Distance from here to here is 1/2. It's starting to look very plausible that, well, if this is a circle, it's certainly got to be centered at 1/2, 0. and have a radius of 1/2. It's got a diameter of 1 from 0, 0 to 1, 1 in rectangular coordinates, or 0, 1, 1, 0 in rectangular coordinates. So that's our circle for r equals cosine theta. The final thing we're going to look at is the graph of r equals sine of 2 theta. Now you caught a glimpse of it. Of course, you got that in your notes there. But I want you to go ahead and attempt to make a table for the sine of 2 theta. And then in the next clip, we'll see exactly what that graph might look like.